right, so it is Monday, day 28. This is our last week of Algebra 1, guys. We're very close to the end. It's so crazy to think. So for your do now today, I had you do some of the things we did last week on Thursday. We talked about systems of equations and how to solve them by graphing. So who can remind me, what is our solution going to be whenever we're graphing two equations? Yes, Michael?
Where the two lines meet.
Yes, just where the two lines meet. It's going to be a coordinate. So all we got to do is graph these two lines I gave you and just see where they're touching. So for our first equation, I have y equals 3 over 2x minus 2. Where would we start if we were trying to figure out how to graph this? What's the first thing I need to do?
Y-intercept.
Yeah, I need to find my y-intercept. What is that y-intercept?
-2.
Yes, remember y equals mx plus b. Our b is our y-intercept. So if we've got a minus 2, that means our y-intercept is -2. So where does my first point go on my graph?
From the 0 in the middle down to.
Yep, you just go to the y-axis and put it wherever it tells you. Right here it says -2, so I'll start at 0 and go down 1, 2. There's our first point, our y-axis, our y-intercept. Perfect. All right, did everybody get that far at least? Okay, if not, this is where we're starting. And then what do we do next to find another point?
Slope.
Yeah, we're going to use our slope, which is 3 over 2. You guys remember what slope can also be written as whenever we're graphing slope-intercept form? Rise over run. Good. So what's our rise going to be? 3. What's our run? 2. Okay, so whenever we use our slope to find a second point, where do we start counting from? Yes, from our y-intercept, from the first point we plotted. We do not start back from 0. Our y-intercept is our starting point. So from my y-intercept, I'll do my rise first. My rise is 3, so I'll be going up 3. 1, 2, 3, right here. Here's my rise. And what do I do next?
Go to the right 2.
That's right. I'm going to use my run, which is 2. So I'll go over to the right, 1, 2. And that's my run. So that gives us a second coordinate right here at the end of our run. Right at, looks like this is 2, 1. And that first point is 0, -2. If you just want those labeled, those points for you. Okay, any questions so far? Is everybody following up to this point? Good deal. All right, what's our last step here?
Draw a line.
Draw a line. Okay, so let's go ahead and draw the line for our first equation. Perfect. All right, are we done? Nope. We got another equation, don't we? So I probably wrote a little too much on this graph. I'm gonna make mine a little messy. I didn't think about that second one. But what are we gonna do for the second equation?
Same thing.
Same thing. We're gonna find our y-intercept, which is +2 plus 2. So I'm gonna go up on the y-axis, 1, 2. Okay, did everybody get to that point? Good. And what do we do next?
Slope.
Slope. What's our slope?
-1 over 2.
Good. -1 over 2. Same thing, rise over run. So what's our rise?
-1.
-1. So I'm going to go down 1. And what's our run? over 2, and that actually lands us right here on the same second point as the first line. So we just need to connect the dots. And that's our solution. Good.
What's the solution?
So our solution is where our lines intersect. So our answer for this question would be 2, 1. Perfect. So we'd put a coordinate down here and we would circle it. That's how you would answer this question. All right. Everybody get that? Okay, before we try number 2, is there any questions that we have about this whole process? Or are we feeling okay?
2, 1. I just have a question about that.
Uh-huh.
I see how about the 2, but what the 1?
So remember our coordinate, the first value is our x value, and the second one is our y value. So we just look on the graph and see where does that point land on each axis. If we were to look on the x-axis, we see it lines up with x is 2, and we see that it also lines up with y is 1.
Okay.
Right there. That makes sense?
Yeah.
Okay, good. Good, good, good. Yeah, no problem. Okay, are we ready to try number 2? All right. So, number 2, I've got 2 equations, but these are a little different. What is different about these? Yes, they are in standard form. So how are we going to find our y-intercept and slope when we're in standard form?
We have to convert the slope-intercept.
Yeah, we need to figure out what our new m is going to be using our negative a over b, and what our new y-intercept is using b equals c over b. So first, let's label our a, b, and c for each equation. On number 2, I've got negative 8x plus 4y equals 4. So what's my A? Negative 8. What's my B? 4. And what's my C? Also 4. Okay, so let's work with this equation first. If I wanted to find my slope, what is that going to be? So we've got negative 8 is our A. So if I want negative A, yes, we've got to switch it. So our negative A is going to be 8. And what's our B? 4. 8 over 4. Can we simplify that?
2x.
Yeah, so that's going to be 2. All right, so we've got our M. How about our B? Yeah, our C, or here, we're looking at the first equation. Our C is what? Yeah, C is 4, and what's B? Also 4. So, our B is 1. So, what's our new equation?
Y equals 2x plus 1.
Good, y equals 2x plus 1. So, that equation is done. And what's our second equation? How are we going to find that? Same thing. So our slope is negative a over b. So what am I going to write for a over b? Good. Negative 5 over 5, which is negative 1. Yeah. That's our b, or sorry, our m. Okay, so we got negative 1 for m. And our b, remember we use c over b.
20 over 5.
20 over 5.
B, 4.
Makes it 4. Good, so let's make our second equation. It'll be y equals,
1x plus 4. Negative 1x.
yes, negative 1x, or just negative x, plus 4. Okay, now we can graph these. And we'll find our solution. Let's start with y equals 2x plus 1. Where's our first point going to be? For the first equation. What's our y-intercept?
No, plus 1.
1. Yeah, we see plus 1 at the end, so our y-intercept is 1. So that's where we're going to put our first point. 1 right there. Okay, everybody got that? Good. And what's our slope? 2. Our slope is 2. So what's our rise over run going to be?
2 over 1.
2 over 1. So we're going to go up 2 over 1 right here. And what do I got to do next? Just draw the line. Good. Before we start the second equation, does anybody have questions, or is anyone confused about how we got any part of this first line?
Well, I'm definitely confused because we wasn't here, so I'll go back and watch the video.
So all we did here that was different is we learned a shortcut to changing standard form to slope-intercept form using these two little formulas here. There's other ways that you could do it, but yeah, I think once you're able to see that video, it'll be a lot more clear. Okay, next equation. What's our y-intercept?
Start with plus 4.
Yep, start with plus 4. So up 1, 2, 3, 4. And what is our slope?
Negative 1 over 1.
Yep, negative 1 over 1. So I'll go down 1 over 1. And we've got the same point being shared again. So it looks like we just got to trace the line between these 2 points. So what's our solution?
1 over 3.
Yep, over 1, up 1, 2, 3. That's our coordinate. 1, 3 would be our answer. Because this is where our lines intersect. That's where they're crossing. So remember, we first look at the x value. This point lines up with 1 on the x-axis, and it lines up with 3 on the y-axis. So that would be our answer, 1, 3. Okay. Any questions before we talk about some other things? Any questions at all? Okay. Before we move on to something else, I want to ask all of you, and feel free to be honest with me. Do any of you feel that you would like to go over this process a little more again today?
I'm confident.
Okay, you feel good, Michael? How about everybody else? What are y'all thinking?
I definitely do.
Right.
I think it's because I didn't watch the video.
Uh-huh.
I don't hold anybody back because I wasn't
Well, and
there.
it didn't upload, so that's not your fault. That's not your fault. Why don't we run through at least 1 or 2 more examples where we have to convert from standard to slope-intercept, just so we feel a little more comfortable. I know it's been the weekend, and sometimes it's tough to remember everything we did, or especially, you know, if you miss a day, it does make you feel a little behind. So before we do some review, I'm going to tell you what we're going to do today other than that. So we are going to do that review of solving systems of equations by graphing, just exactly what we did above. And then we're going to introduce 2 new things. We're going to talk about linear inequalities. You guys remember inequalities? Where we would have a circle that was open or shaded, and then we would shade to the right or to the left, and it was less than, greater than, less than or equal to, greater than or equal to. Yeah. These can be graphed also, so we'll talk about that today. If you know how to graph a line, which you do, this isn't going to be as hard as it sounds. And then at some point, we're going to talk about what's going to be on your final this Thursday. Now, I'm going to offer this to all my classes. We're going to try to have everything covered by tomorrow for the final, so that if you want, you can take it on Wednesday, get it knocked out, get it done. Or if you take it Wednesday, don't feel great about it, then you would have time to retake it on Thursday. So yeah, any questions about that? Okay, well, let's do a little bit of review on those systems of equations. So let me go back to, I've got some written out, that'll be.
What if you bomb the final, but you've done good? I mean, how much of your grade does it affect?
So your final is worth about 50 points, and let me check on Synergy. Hang on, I'm going to pause this. So, good suggestion here. We're going to do the exit tickets. Since these are going to be optional this week, exit tickets during finals week, I'm not grading them. Yes. We don't need extra work on top of trying to prepare and get ready.
My kids told me, Mom, just do what you tell us, just relax.
That's right.
Focus, Mom.
That's
You can do
right.
it.
That's right. And you guys are all in great shape. If we're looking at your grades, I'm not worried about any of you. You're all going to pass. So let's look at this as our example problem. We want to solve the system of equations by graphing. So I've got two equations here. Y equals 3x plus 1. That one is already in slope-intercept form, so we don't need to do anything to it. Then we've got 5x plus 2y equals 10. Ax plus by equals c. So we're going to need to figure out our slope and our y-intercept from this equation. And I'm going to walk you through just real slowly, step by step, how to do that. So remember, ax plus by equals c. In order to start the process of rearranging and figuring out our new equation, we want to start by labeling the a, the b, and the c. So what's our a going to be? 5. What's our b? 2. What's our c? 10. Good. So let me pull something else out from the other day. And Joe, I'm going to give you this because I totally forgot I had it. Here are the notes you missed on Thursday. And this has got a whole little guide of steps to figuring out how to do this. So hopefully that helps.
Kind of helped me out.
Yeah, so let me go back to that for everybody. This is what I just gave to Joe. This is our notes from Thursday. Okay, so we did a lot of this conversion. Here's where we got slope is negative a over b and our y-intercept is c over b. So whenever we rearrange that ax plus by equals c and get it into y equals mx plus b, you can see in the m spot, we've got negative a over b after rearranging. In your little b spot, your y-intercept, we've got c over b left. So instead of making you guys rearrange all the equations every time, we're just going to use those negative a over b for slope and c over b for y-intercept. So now that we've got our a, our b, and our c, let's find our slope and our y-intercept. All right. So, what numbers are we going to use for slope?
Negative 5 over 2.
Good. Negative a over b. So, negative 5 over 2. Okay. And do we need to simplify anything, or are we good? We're good. We're good. Yes. So the do now that you missed is up at the front. And right now we are actually doing the exit ticket problem. If you want, that's also up there.
Is it the same one we had last week?
Yes. All right, so we got our slope. And what's our y-intercept going to be?
10 divided by 2.
Good. B or c over b. So 10 over 2, which is
5.
5. Good. Now, quick shortcut for you guys that I didn't mention on Thursday, but might be helpful in the future if you're trying to work a little more quickly. Once we have our y-intercept and our slope, do we really need to put it into a new equation to graph it, or can we just graph it with this? You can graph it from this. I know where to start and I know my rise and run. So if you want to save a step, you don't need to rewrite the equation unless you just want to. If it makes you feel better, go ahead. But let's go ahead and just do it from these points that we found. So our y-intercept is 5. Where does my first point go?
Start from the 0 and go up 5 on the y.
Yeah, start from the 0, go up to 5 on the y-axis. So 1, 2, 3, 4, 5 right here. Right at the top, that's right.
Over 2.
Yep, and then I've got my rise over run, which is
Negative 5 over 2.
good, negative 5 over 2. So we usually do our negative 5 first, but you could do the over 2 first as long as you do it in the right direction. So we've got down 5, 1, 2, 3, 4, 5, over 2, 1, 2. Right there, that's our second point. Everybody see how we got that? Good. Let's connect the dots. Okay, we just have one thing left to do. We need to graph that first line and see where they intersect. So where do we start?
Plus 1.
Yeah, plus 1. That's going to be our y-intercept. So I'm going to go to my y-axis. And where am I going to put my first point?
Go up from 0 to 1.
Yeah, go up from 0 to 1, right here. That's my first coordinate. And what is my next step?
Rise over 1, 3 over 1.
Yes, my slope is 3. And in rise over run form, that'd be 3 over 1. So where am I going to go to plot this?
Start from the 1.
Start from my y-intercept and go up 1, 2, 3, and over 1. All right. So we got those. Now we just got to connect the dots. And we're going to get an intersection that's not a perfect point here. That's all right. We'll just make a little bit of an estimate. So here's our intersection right here. If you could make an estimate, what would this coordinate be?
I got 0.75
Uh-huh.
and 3.1.
Yeah, sounds good to me. So we can tell that on the y or the x-axis, we're going over not quite all the way to 1. So about 0.75-ish, about 3/4. And we're just guessing here. I'm not going to ask you to find these exact numbers. And then we look at our y value, and it looks like this intersection here goes up 1, 2, 3, a little above 3. So Michael suggested 3.1, which I think sounds good. Okay, you guys see how we did that? Okay, Tasha, what part are you not seeing here?
I was looking down.
That's all right. Is it the coordinate that we found? Are you
Yeah.
confused about getting these numbers?
Yes, right at that 0.75. I was looking down. trying
That's
to
all right.
what we just
Here,
got.
we'll talk about it. So first, remember our
0.1,
x value is where it lines up on the x-axis. So the way we got 0.75, this is just an estimate. We don't know the exact number, but I can tell that my point lines up not all the way to x is 1, a little below, about 3/4 of the way. So we just estimated a decimal about 0.75. That makes sense?
Okay, it does.
And then same thing for the y. We saw that on the y-axis, it lines up just a little bit above 3. So again, we made an estimate of about 3.1. Just a guess. I would even be fine with just 1.3. Be close enough. Okay. Any other questions? I appreciate you saying something. Okay. We feel okay about this? All right. I'll try to get you guys some more practice problems on these here soon, but we're gonna go ahead and move on to something new. This will be one of the last new things that we introduce in algebra. We're gonna learn about linear inequalities. Okay, does anybody still need this note page, or can I move it? All right. So just like I said on your topics list, we are going to talk about linear inequalities and systems of linear inequalities. So something I noticed, I'm just kind of thinking out loud here, is on Thursday, whenever I did the guided note packets, as much as I like having those to just give you and you guys can look through them, I feel like we catch on better as a class and you guys grasp the concepts better when I have you write the stuff yourself. So I'm fine with giving you guys like the do now and the exit ticket moving forward, but I am gonna have you guys copy and write these notes yourself since it is something new. That way I just think it'll stick in our brains a little better. So let's start a new sheet of notes. We're gonna create a little guide. If you need graphing paper, feel free to grab some from the front of the room. And I'm going to have you name this page Graphing Linear Inequalities. And I'm going to write that out for you up at the top. Okay. So graphing linear inequalities. So this is going to be a little guide for you. Okay, once you've got that title, we're going to create 4 little graphs, and I'll show you where I want you to put those. Let me find my ruler. Here we go. So we're going to draw one right here over to the right side. Not too big. We're going to do some smaller ones. I'm just going to get the spacing first. 1, 2. Hope I made enough room for 4 because we need 4 of them. 3. Show ya. And 4. It's alright if they're not perfectly even and the same size. Just want to be able to fit 4 of them on your page so we can see all the 4 types. And don't worry about drawing tick marks or anything. We're not putting anything super exact on here just yet. We're just going to create a little picture guide first. Okay. Once you've got your 4 graphs, and I'll give you guys a minute to do that. Once you're there, I am going to have you call the first 2 graphs So maybe we'll draw a little line in between. My first two graphs are in the greater than category. So create a big greater than sign and leave space in between. Once you've got that big greater than sign, we're going to put a less than sign on the bottom half. Now these linear inequalities, I'm actually excited for us to start playing around with because I really enjoy these. I think, you know, you guys already know how to graph the equation of a line, and whenever we're doing these, we're only going to look at slope-intercept form just so there's one less thing to worry about. But I think when we draw these, it's kind of satisfying. I think you guys will like it. So let's get everybody up to that point. Everybody's got a big greater than and a big less than. And then I'm going to focus on the top two first. Does anybody need to see that bottom half, or can I stay up here? Okay, I'm going to pause this video and give you guys a minute to catch up. Okay, so a linear inequality is super similar to a linear equation. So a linear equation is just y equals mx plus b. A linear inequality, the only thing that changes is the equal sign. Instead of it y equals mx plus b, for our first example, we're going to put y is greater than or equal to mx plus b. Okay. So to show what this graph would look like, I'm just going to draw a random line. It's not going to have to be super particular. It doesn't matter what points it goes through. But I'm just going to draw a line here. Nice solid line. And what this means, y is greater than or equal to mx plus b, this symbol is telling us which values make the inequality true. So just like whenever we would do, you know, x is greater than or equal to something, we would write that number and then shade all the values that x could be. On a graph, we're not just going left to right to shade. This time we shade up or down. And we're not just shading a line, we're shading every single coordinate in between. So if y is greater than or equal to mx plus b, do you think we'll be shading up or down? Up, because it's greater. We're looking at the y is greater, so we're looking up and down. And we're going to shade up. If you guys want highlighters, I've got a whole bunch over there. Highlighters are fun. Or you can do like what I did here, little scribbles, or like cross hatching. But that's how we draw this graph. Y is greater than or equal to mx plus b. So you just graph the line like normal and then you decide where to color it. That's the only new thing we're adding.
That goes to infinity, right?
Yep, to infinity, absolutely. Never ends.
here.
Yes, yes, you would.
You need some? My kids got me gel pens, and I forgot about
Yeah, and guys, I do have a ton of markers and highlighters over there on that shelf. If anybody wants to use them, feel free.
We're addicted to them.
I know it, girl, me
I love
too.
it so much now.
Okay, let's look at the next type of greater than. So I showed you greater than or equal to first because what it's telling us by saying or equal to is that any of the points on this line are included. These are included. So that's why we can draw a straight line and not make it look any different. But if we had something like this, y is just greater than mx plus b. It's going to look a little different. So before you get ahead to drawing the line, don't do it just yet. I want you to watch how I draw it because it's a little different. To show that it's not equal to, it's just greater than, that means the line is not included, we actually draw a dashed line. We don't fill it in. It's just like the open circle versus the closed circle. We do a filled in line versus a dotted line or a dashed line.
Still got one for me in there?
Yep. And then we still do the same thing with the shading. The only thing that's different is whether your line is dotted or not. That's it, guys. That's really the only thing that's new about inequalities, linear inequalities. And since it's greater than, we shade up. Now, let's say you got ahead of yourself and you forgot to make your line dotted or dashed. I'm going to show you what you can do in that scenario so you don't have to totally start over. I'm going to fill this line in first. Okay, so let's say I drew my line and I was like, oh my gosh, I was supposed to make that a dotted line. Here's what you can do to show me it's supposed to be dotted. Just create little dash kind of next to it like this. That way I can tell, like make it very obvious that it's supposed to be a dotted line. You see how I'm doing that? You're just going to draw it kind of right under it or above it just to show like this is supposed to be dotted. I should not have to guess whether it's dotted or not. You always want to make your answers as obvious as possible. So this is greater than. And that top one was greater than or equal to. So I'm going to label those. So that's the only difference. It's going to be a dotted line versus a normal line. Okay. You guys have any questions so far about this? Okay. Well, I bet you guys can already guess what the second half of this guide's going to look like. It's going to be the exact same thing. Ooh, that scared me. I swear. Okay. So let's go ahead and create the less than part. Huh.
Before this, I know it is. Everything
I
else
was
is
just
so
gonna give you
simple.
that, just shade lower.
Yeah, you know,
Yeah.
this is good. That's it.
Right. So this time we'll have y is less than or equal to mx plus b. And y is less than mx plus b. And I'll go ahead and label that before we draw our line. Less than or equal to. And the second one is just less than. Okay, so for the less than or equal to, we're going to draw a similar line to what we drew above. And is our line going to be dotted or solid?
Solid.
Solid. This one is less than or equal to. So to make sure that we know that it could be equal to the line, we keep it a solid line. So that's kind of the terminology that we use here. We say dotted or solid. So now that we've got our line drawn, are we going to shade up or down?
Down.
You're going to shade down this time. Good. This time you'll shade down to show that it's less. Okay. Blurring my lines. So that's the only difference there. It's just where you shade it. And how about for just less than? Y is less than mx plus b. Is our line going to be solid or dotted? Dotted. Good. So I'll have you guys go ahead and finish out that guide. And this will be something that we can look back at and reference in case we forget which way it's supposed to go. So keep track of this paper. And I'll give you guys a minute to finish writing that if you're not done. I'll pause this and then we're going to do some practice on this when we unpause it. Okay, so I want us to practice, and let's do, I'll zoom in on this. Let's try graphing the linear equation y is less than negative 1/2 x plus 2. So go ahead and draw yourself a graph. It doesn't need to be too big. You can tell that we're not going to be moving any more than 2 in the y direction and looks like 2 in the x direction, so you don't need too large of a graph. Probably just do about that big for mine. Didn't have to be perfect. I'm going to get my tick marks on there. And I'm going to label my x-axis and my y-axis. Always good to label everything. It helps you keep from getting those mixed up. Okay, so once you've got your graphs drawn, let's go ahead and start by figuring out what our first point on this line is going to be. What should I look at to figure out my first point?
Y2.
Yeah, my y-intercept or my b, and in this case it's a positive 2. So where's my first point? Up 2 on the y-axis. Our point is 0, 2, if we want to be specific. Perfect. Now, if I wanted you to be really accurate with this line, since it's less than, and it's not less than or equal to, we actually wouldn't want to shade this circle. We would want to keep it open. But I'm not going to get that particular on it. I'm all right with you just having it shaded. I think sometimes these are really tiny, so it's okay. I don't know if I could make mine look open. Maybe I could use some white out. But if you don't have an open circle on your final, I'm not going to take points off. I'm more so looking to see that the line is open. Okay, once that dries, I'll make a better circle.
So normally it needs to be an open circle?
Yeah, whenever we get into tougher stuff, like maybe in Algebra 2, I'll want you to be more specific, but I'm just worried about the line being dotted or solid. It's okay if your dots are not open. I'm not really grading you on that. Okay, well.
But it's a good habit to get into.
Yeah, it's a good habit to get into.
Yeah.
Just know that I'm not gonna take points off if you don't. It's no biggie.
So we don't need the first dot, we need to find the second dot.
Yeah, now we just need to find our second dot, and we use what to find that? Slope. Good. Our slope is -1/2, so where are we gonna move on our graph?
Down from U1 and then over to the right.
Yes, we're gonna start from our y-intercept, and we're gonna rise -1. We're gonna run +2. So our second point will be right here. Now we just need to connect the dots. Now before you connect the dots, remember we want to really pay attention to our symbol. What symbol is here in this equation? Or inequality? It's less than. Should our line be dotted or solid?
Dotted.
Dotted. So let's do a dotted line whenever we connect the dots. Okay. So once you've got your dotted line on the graph, we need to decide what direction do we shade? Up or down?
Down.
Down. Good. It's less than, so we shade down. Here we go. Perfect, perfect. I might stick with the scribbles for today because my highlighter bleeding is bothering me. All right, everybody got that? Awesome. Awesome, awesome. I'm gonna give you another inequality after that.
Now on the tests and stuff like that, when we start doing it, it needs to be solid in, or can,
So
it needs to be more like this?
I'm not gonna be a stickler, I guess. Like as long as I can see that you shaded below the line, I'll know that it's supposed to cover everything. I like this scribble here, that's fine. You could even, if I don't know, your pen's running out of ink, you could even draw arrows to show this is where I'm shading. That's fine too. Okay, let's try y is greater than 2x minus 2. So we'll draw another little graph beside it. Okay. We're going to label our x and our y axis. And once you've got that graph drawn out, what's going to be our first step? Yeah, graph our B or our y-intercept. Yes, -2. So are we going to go up 2 on the y-axis or down 2? Down 2. Good. Now, if we want to be real technical for this point, should it be shaded or open? Open, because it's greater than. It's not greater than or equal to. Again, I'm just giving you that for sneak peek into later things, but if you don't have an open circle, I won't be taking points off. I'm more worried about the line being dashed or not. Okay, so we just graphed our y-intercept. What do we do next?
You need a dotted line.
Say it again.
Oh, rise over run.
Yeah, we need to use our slope to find a second point, rise over run. And in this case, what's our rise? 2. What's our run? 1. All right, so we're going to go up 1, 2, run 1. So we're going to end up at this point, which is 1, 0. So +1 on the x-axis. And before we connect our points, are we going to have a dotted or a dashed line or a shaded in one? Dashed. Why do you know that it's going to be a dashed line? Yes, because it's not equal to, so we do not include the line. So we're going to make a dotted line right here between these 2 points. And once we've gotten our dotted line drawn, what direction are we going to shade, up or down?
Well, right.
We'll hear 2 different answers. Which one is it?
Or what up?
Up. Why are we shading up? Because it's greater. Whenever something is greater, we shade up. If it's less, we shade down. So we want to shade anything above our line. And that would include all this over here, because this line goes on forever. Goes on forever. That's right. That is right. Love it. Awesome. All right, guys. That's not so bad, is it? No, this isn't so bad. I know. I feel like the more kind of visual stuff where you're figuring it out based on what it looks like, I feel like those are a lot easier for you guys sometimes. I know this was always easier for me when I was in high school. I like visual stuff. Okay. Would we like to practice some of these a little more, or do you want to try systems of inequalities? Y'all want to try systems? Okay, let's do it. Let's do it. Okay, anybody still need this page? Great. Okay, so here's what we're going to do. I am going to give you 2 inequalities. Let's do y is greater than 3 over 2x minus 2. And y is less than -1/2 x plus 2. We did this system of equations this morning, or not this morning, but earlier for our do now. So whenever we are given a system of linear inequalities, it is very similar, almost identical, to graphing a system of equations. You're just going to graph these 2 lines. And we're going to find the intersection. Although this time the intersection isn't just going to be a point, it's going to be a section where the shading overlaps on the graph. So let's go ahead and draw ourselves a little graph here, and we'll do this together. Probably made it much bigger than I needed to, but that's all right. Okay, make some tick marks. All right. Once you've got your graph ready, give everybody a second to write all that down. But we'll start graphing these and see what happens. And this will probably be the last thing we do before lunch because we've got 2 minutes left till lunch starts. Okay guys, so real quick, let's start with the first inequality. Somebody read me what this inequality says.
Y less than,
Whoa, try again.
sorry, y greater than
There.
3 over 2 plus
You got it, girl.
x minus 2.
Perfect. So we've got y is greater than 3 over 2x minus 2. Where do we start when we want to graph this?
Minus 2.
The minus 2. That's going to be our y-intercept. So our first point will be at -2 on the y-axis. And where do we go from here?
3.
Yeah, we're going to do our rise over run. Our rise is 3. So 1, 2, 3. And what's our run? 2. 1, 2. Here's our second point. Now, when we connect these two dots, are we going to have a solid line or a dotted line? Dotted. Good. It's greater than, not greater than or equal to. So we want to connect those. Okay, let's do our second line real quick. What's our y-intercept? Plus 2, so I'm going to go up 2 on the y-axis, and where's my second point going to be? Yep, we're going to go down 1 over 2, so we've already got it. Okay, so let's connect the dots. Is it going to be a dotted line or a solid? Dotted. Dotted, dotted. Good. And then we need to decide our shading. Okay. So, for our first line, what direction do we shade, up or down? Up, because it's greater than. So I'm not going to fully shade just yet. I'm just going to draw some arrows that tell me what direction I'm shading on my line. Okay, so I've got my arrows. And what direction do I shade on the second inequality? Down. So again, I'm not going to shade just yet. I'm going to draw my arrows that tell me what direction to shade in. Okay. So once you've got all your arrows, we got to decide where we're shading this system of inequalities. And here's what you're looking for. You are looking for where the line shading overlaps. So I've got arrows pointing towards each other in this section. You guys see that? Over here, I'm not going to include this or this because what I'm looking for, yes, is just the overlap. So my solution would be this area here. Does that make sense, guys?
Yes.
Awesome. Okay, I don't want to keep you too long right now because it is lunchtime. It's actually 11:57. So we are going to do a teeny little bit more practice after lunch. If you cannot be here after lunch, I'll make sure today before I leave that those videos do get uploaded. And we'll talk a little bit about your final coming up here soon. But I'm going to pause this recording for now. And if you need to get out of here, I know I kept you a little long. So, right before lunch, we did this really quickly because we were running out of time. We did a system of linear inequalities here. So, all we did, just to recap, is we graphed y is greater than 3 over 2x minus 2. That was this one here. And we drew arrows to show that since it's greater than, we would be shading up. Then we did the graph of y is less than negative 1/2 x plus 2. And here's that line in red. And we drew some arrows to show that since it's less than, we'll be shading down. Now, whenever we have a system of linear inequalities, the reason that we start with arrows instead of just shading right off the bat is because we only want to shade the part that overlaps here. So instead of starting off with shading all of this and then having to see the overlap and it getting a little muddy, we decided to just wait and see which part would be touching, which is right here. So before we do another example, does anybody have questions about this one? Okay, great. Let's move on.
You do another one like this?
Yes, we're gonna do a couple just like this since this is new.
All right.
Let's start now with y is greater than or equal to 2x plus 1 and y is greater than negative x plus 4. So here's a whole new system of linear inequalities. Before we graph, let's go ahead and draw our x and y axes so that we have somewhere to put our lines. Okay. All right, so I'm going to create some little tick marks too. Hello. We're starting another example of those systems of linear inequalities. We haven't started working it out yet. We're just drawing our graphs right now.
Perfect timing.
Yep, good timing. All right. And we want to put our x and our y on there so that we don't forget which axis is which. And I'll give you guys a minute to get caught up to there so that we're all kind of on the same page. Okay. Let's go ahead and look at this first linear inequality. Can somebody read out to me what this linear inequality is, how you read it, how do you say it?
Y is greater than, less than 2x plus 1.
Super close. You got greater than right.
Oh, greater than 2x plus 1.
So greater than or what?
Equal to.
Yes, greater than or equal to. So Tasha, you are not the only one that does that. It's really easy to kind of like, your brain goes into auto mode and you're like,
Looking, I was like, that's what it is.
So there's no such thing as greater than or less than.
No, it's not.
That wouldn't work. So remember, this line underneath our sign means greater than or equal to. Yeah, greater than or equal to. Oh, you're all right, girl. You're all right. Okay, so first of all, is this line going to be dotted or is it going to be solid? Solid. So let's go ahead and I like to just put a little solid line next to it so I don't forget. And how about the second linear inequality? Is that going to be dotted or solid?
Dotted.
Dotted. Why is this going to be dotted?
Because it's only greater than.
Yes, this one is only greater than. It's not also equal to, so our line is not part of the solution. So this one needs to be dotted whenever we draw it. So let's go back to that first one. When we are graphing a line, whether it's an equation or an inequality, it doesn't matter. What's our first step?
Y-intercept.
Yeah, our y-intercept. We want to identify that first. And in this case, we've got 1. So where does our first point go?
0, 1.
Perfect. 0, 1 on the y-axis right there. There's our y-intercept. What's our next step?
Slope.
Yeah, we want to use our slope to find another point. What is our slope here?
2 over 1.
Yeah, we've got 2x. So if we were to make that into that rise over run, any whole number as a fraction is that number over 1. So our rise is 2, our run is 1. That means we're going to go up 2 and over 1. So there's our first line. And what did we say earlier? Is this line going to be solid or dotted?
They'll only be solid.
Yeah, this one's solid. Let's go ahead and draw that solid line, just so we've already got it on there.
Now, are these supposed to be open circles as well?
So because it's greater than or equal to,
They can be
they can be,
solid.
yes,
Okay.
solid line, you've got solid circles, solid points.
Perfect.
Whenever we've got a dotted line, that's whenever our points should actually be open.
Okay.
Good question. Okay. There is our first one. All right, you ready for the second line? See a couple people still writing. I'll give us a minute. Okay. Where do we start for this second line?
0, 4.
Yes, we've got our y-intercept, which is positive 4. So we're going to go to the point 0, 4 right here. Okay, and how do we find our second point?
Negative 1 over 1.
Yeah, when we have negative x, that's really negative 1x. So remember, any whole number as a fraction, you just put it over 1. So our rise is what?
Overrun.
Yes, we've got rise negative 1, run positive 1. So I'm going to go down 1 from my first point and over 1. And looky there, we've got a nice intersection with that original line.
Isn't our second our first? The one on 4, isn't that?
Yep, I reused the equations from Arduino. I just put signs in there. Now,
Since that one's not equal to, that one's supposed to be empty, right? The dot.
you're correct.
Oh,
You're
okay.
correct. So this one, and again, I'm not testing you at all on if your dots are shaded or not. I'm really looking at if you have a solid line or a dotted line. So don't worry too much about that just yet. Now, in this case specifically, I'm not sure, since the solid line goes through that point as well, I don't know if it would be open or shaded. I'm not sure. I feel like it would probably be shaded since it's included in that first equation, or inequality. I don't know though. I'd have to look into that. Okay, we've got 2 points. Is our line dotted or shaded?
Dotted.
Dotted. So make yourself a little dotted line. And then we got to decide where to shade for both of the lines.
I know where.
Okay. So we've got our 2 lines graphed. How are we going to find out what part will be shaded in? Star?
It's gonna be on the left because both arrows, the arrows are gonna be facing each other, not going away from one another.
Okay, so when you say on the left, what do you mean?
Where the arrows, see where it meets?
Right here?
Yes, be on that side there.
You want to shade it up?
Okay, so let's check. My first equation, I did that one in blue. I've got y is greater than or equal to. So on this line, I'm shading up or down? Up. So that means anything from this line and up is shaded. And on my second line, it's also greater than. So that means I'm also shading up from this line up.
Yes, I was thinking in negatives, yes.
Ah, so where's my overlap?
In the top.
At the top, right here, right here. That's right. So we are gonna shade this section here.
Oh,
Yeah.
you got me.
I know it's tricky, guys. It's a little tricky.
Yeah, right.
I love it. So that is our overlap. Now, if you're ever wanting to do a double check, this is something you could also do. If I wanted to draw about where I'm going to be shading, I know I'm going to be above this. Okay, and I am above my dotted line. I can then see where my purple and blue are together. You only shade the part that overlaps. Yeah, does that make sense?
Yeah.
Good. And you could even look at it here.
Yeah, it's super cool.
If you need to use more than one ruler, like if you use these clear ones, here's another way to look at it. I'm going to think of the purple as being the greater than on my blue line. And then I could think of this blue as being the greater than on my other line. And you see I'm going to shade where the rulers are overlapping. You see that? So on your final, whenever we ask questions like these, feel free to use 2 rulers if it helps, really. Because then you know that I'm shading where they're touching. Make sense? Good. Good, good, good.
But your picture still looks awesome.
It does. It looks, that actually
That is
looks
bad.
good. You know, something to sketch up to, where like it will come out and you can imagine how
You guys are funny.
Oh my word.
All right, does anybody else still need this?
I am so in here.
Any more? Anybody need to write still? Or can we move on?
We can move on.
Okay, let's do one more together and then I'm going to have you guys try some on your own. Let's see. I want to find some good ones that will overlap. Let's do y is less than 2x minus 4 and y is less than negative 3/4 x plus 3. Okay, I have no idea what this one's going to look like. I just came up with some random inequalities, so we'll see together.
Oh, goodness.
It's going to be a mystery for both of us. So let's go ahead and draw our x and y axes so that we can graph this. Oh boy. Oh, you guys.
Oh, Miss Taylor.
What?
Sometimes you spook me.
I spook you.
As I told you, you were quite the
That's
spooker.
right. You don't know what it's going to turn out to be.
We're going to find out. Well, I try to give, you know, my y-intercepts, I try to make them small. And I tried to make my slopes not too crazy either. So I think they'll turn out.
Okay.
I think they'll turn out.
All right, fine.
They'll at least be visible.
Yeah.
Yeah, that would be an issue. They're just off the graph completely. Okay. Let's make these here.
So my highlight is making all this different color because I keep going across to it like blue and
Uh-huh.
pink, and so it's coming out like purple.
Oh my gosh, that's funny.
It is.
I swear.
Gosh, I can't wait to show my kids.
They're gonna love that.
I know, right?
All right. We are just about ready to start graphing these. I'll give you guys a minute to catch up. Okay, let's look at that top one. Somebody read it to me.
Y is less than
Uh-huh.
2x minus 4.
Yes, y is less than 2x minus 4. Where's my first point?
-4.
-4 on which axis?
Y.
Y, yes ma'am. So, here we go. 1, 2, 3, 4. There's my first point. Yes ma'am. All right, how do I find my next point? Uh-huh. I'm going to use my slope, my 2 over 1, my rise over run. I'm going to go up 2 over 1. There we go. Now, if I was being technical, these circles here, or these points, they would be open. But it's all right. I already colored them. How about our line? Is it going to be solid or dotted?
It's gonna be
Look at our sign.
It's done.
Michael, you're right. Why is it going to be dotted?
It's not false equal to.
Yes. Remember, if it is just less than or just greater than, we don't have a solid line. We'd make it dotted to show that it's not equal to. It's just less or just greater. So we're going to make a nice dotted line here. Okay. And we'll wait on the shading until we get our next line drawn.
I just did what you said that we.
Huh.
Yes, I did. So little dots go beside it.
I had to do that too. I want them already.
Already.
Oh, yeah. We got it though. We got it.
Yeah.
We got
Yeah,
it.
you do. Okay, I'll use a more high contrast color here. I'll use pink. All right, guys, let's look at our second one. Y is less than -3/4 x plus 3. Where's our first point?
Oh, it's gonna be 3.
That's right, girl. On the Y axis. 1, 2, 3. There we go. How do we find our next point?
-3 over 4. So
Uh-huh.
down, net 3.
Down 3.
And over 4.
1, 2, 3, 4. There we go. Is that line going to be solid or dotted?
It's gonna be.
Dotted. That's right. Yes.
Sing
I love it. All right. So let's do that. Let's make a nice another little dotted line. Now, as we're making this dotted line, let's think about the direction we're shading on these. What direction are we going to be shading for both?
Maybe down.
Up or down?
Down.
Down. That's right. We've got less than for both. So let's use our ruler trick. If you want another ruler, you can come up and get one. But what I'm going to do here is I got a blue line, I got a pink line, I got a blue ruler, I got a pink ruler. So I'm going to put my pink one under the line because it's less. I'm going to put my blue one also under the line because it's also less. Where am I going to shade?
That middle bottom part.
Where it overlaps, right here in the bottom middle section, guys. Very good. That's our overlap right here. So we just shade. I'll make it purple because the colors mix.
I'm gonna make it blue.
Yes. I love it. All right. There we go. And that is our graph. That's the solution to this system of inequalities.
I like this.
I like it too. Well, good. I love it. I like all the visual stuff. I think it helps.
And that's the one that we get bonus points on.
No,
This solving, no?
not this one.
Not
The
this
one that might be, probably will be bonus points because we aren't going to get much time to go over it, is solving systems of equations. Not by graphing because you guys got that. What is probably going to be bonus is these two methods here where we use substitution and elimination. And we'll talk about those soon.
Okay.
Talk about them soon.
Okay, I kind of like to put a little bit.
Yeah. All right, y'all feel good about these?
Oh gosh, yes.
Good, good.
Love it.
All right, I'm gonna give you guys one to do on your own, and we'll look at it together. Okay, so let's do y is greater than or equal to 1/2 x plus 1. And y is less than or equal to 3x minus 3. Okay, I want you to graph the solution of those two linear inequalities. I'm going to pause the recording and I'll set a timer for you guys. All right, guys, what are your lines looking like?
Is looking like one.
Yeah, let's do this first one. 1 is the y-intercept, perfect. And then
Right over 1 over 2.
1 over 2. Just like that. Shaded or dotted? Or sorry, solid or dotted? Solid. What about the other one? Is that one solid too or dotted? Both of them are solid. All right, so there's our first line and our second one. Huh? Yeah. -3, 0, -3 is that first point, and slope's going to give us another point. Where?
Up 3 over 1.
Up 3 over 1, right at 1, 0. So here's that one. And that's solid, you guys said. Uh-huh. That's a rock. Oh my gosh. All right, so which direction are these going? How about the pink one? What's this sign say?
Going up straighter.
Greater than or equal to, so that means we're shading up.
Oh, yeah.
So I'm going to put my ruler above that line. And how about the second inequality?
Shade down.
Yeah, that one's less than or equal to, so we shade below the line.
I got it wrong.
Uh-oh.
Dang it.
So where's the overlap?
On top.
Right here. So whenever you have a line that's really steep like this, it can be super tricky to remember which direction is up and which is down. Just remember that any point on your graph, you're going straight down from it. See that?
Definitely going to, yep, I didn't do that.
That's all right. And this one, we're going straight up. Here's where they're touching in the middle. So I'm going to shade this upper right-hand portion here where they overlap. Just like that. There you go. Star, what did you shade instead? Did you shade down here?
Down.
Ah, gotcha. So this one is the, did you make this one also less than? Is that why?
Yeah, I messed up.
I gotcha. That's all right. That's all
Oh, I
right.
got the lines right.
You got the lines right. That's good. So we just got to be real slow and careful about our directions. We got to remember that we're looking at the y, whether it's bigger or smaller. The y is bigger, so we shade up. The y is smaller, so we shade down. There's our overlap, guys. Okay, how we feel about these? Feel good? Feel good?
Oh yeah, I feel good.
Good.
Screwed up.
Good.
Admit my failure. Oh.
Okay.
It happens.
How do we feel about introducing our last new thing that you'll learn at all in Algebra 1? Let's introduce it, okay? Because here's the deal. These two things that we're going to introduce, they're going to be worth bonus points since I'm not giving you much time to practice them. So these are bonus. And these you don't have to graph. It doesn't involve graphing at all. So you can do it on regular paper if you want. And for the sake of your notes looking like mine, I'll use regular paper too. So we are going to title this Solving Systems of Equations. And we're going to learn 2 new methods. So, the first method we're going to learn about is called substitution. Substitution. So I'm going to give us 2 linear equations, and I'm not totally sure if they're going to come out super pretty or not, but it'll work. So let's do, let me write in black. Y equals 2x minus 1. And y equals -1/2 x. Without me telling you, do you guys remember, because of these slopes, do you know what kind of lines these are going to be?
Perpendicular.
Yeah, these are perpendicular lines. This slope, 2, is the negative reciprocal of -1/2. Little throwback for you. These are perpendicular lines. Good job. If you didn't know that, that's okay. We're going to talk more about them later this week. Let's do +1. Okay. So, let's say we don't have access to graph paper, and we want to find our x value and our y value that will be the solution to satisfy both of these equations here. So we don't have a value for x to plug in or a value for y. There's going to be a special way that we solve this without using any outside pieces at all. So I'm going to walk you through this, and I want you to kind of follow along. So I have in my first equation y equals 2x minus 1. In my second equation, I have y equals -1/2 x plus 1. Since we don't have any specific number values to plug in for either variable to solve, what we can do is say, well, I know that y equals 2x minus 1. Why don't I put 2x minus 1 in for y right here? So that way I only have x to solve for in this equation. Let me show you what that's going to look like. 2x minus 1, that's what I'm plugging in for y in this equation, equals, let's do -1/2 x plus 1. Okay, before we go any further, do you guys see what I did there? You guys see how I was able to put these equal to each other? If you don't, tell me.
Okay, you said the 2 is the -1/2x is the opposite of 2x, right?
Yes, it is. Now that won't matter for this, I was just pointing it out. So basically what we did is we took the value for y that we were given here. We know that y is 2x minus 1. Once we know what x is, we know what y is. We don't know what either are yet. So we're going to try to simplify, and we're going to substitute this here into y right here. Let's work this out and see what happens. Okay. So now I've got 2x minus 1 equals negative, oh, I'm just rewriting it first. Negative 1/2 x plus 1. Now I have an equation here with x. X is the only thing I need to solve for. So we are really just going to be doing solving an equation like we normally would. So what would my first step be here?
Move the x over.
Yeah, we want to get our x's on one side. We're going to combine our like terms. So should we move 2x to here, or should we move negative 1/2 x over here?
Let's move negative 1/2.
Yeah, let's move negative 1/2 x. I don't like to have negative x's. So how would I get rid of that? If it's a negative plus 1/2 x. Good. I'm going to do that on both sides. You remember doing stuff like this, guys? It's been a while. What happens to my 1/2 x's over here?
Cancel.
They cancel out. So now I've got 2x plus 1/2 x. What's that going to give me?
I got 3.5.
So 2 plus 0.5, or plus 1/2.
I would do 3 over 2x.
3,
Or I'm sorry, not 5 over 2x.
you could absolutely do that. So here, let's talk about what's happening here. We've got basically 2 plus 1/2. We could also think of it as 2 and plus 0.5. We could also think of it as 4 over 2. That simplifies to 2 plus 1 over 2. So here's all the different answers that would work. You could either get what Jeremiah said, get 5 over 2 if you want to keep it as a fraction. You could get 2.5 if you prefer decimals. Or you could have a mixed number, which I would not suggest. Mixed numbers are a little tricky to play with whenever it comes to algebra. So I would really suggest either one of these two. Okay, for simplicity, I'm going to write 2.5x. Is everybody okay with that?
Yes.
Okay, so I got 2.5x. And what do I need to do now?
Bring down the rest.
Bring down the rest. I've got minus 1 on this side equals positive 1. Okay, what's my next step?
Get rid of the 1.
Get rid of the 1. I've got minus 1, so what should I do to get rid of it?
Plus 1.
Plus 1 on both sides. What happens to my negative 1 and my plus 1? They cancel. Good. So then I want to bring everything down. I've got 2.5x equals 1 plus 1. What's that? 2. Okay, what's my next step? Divide by 2.5. Good. Because we want to get x by itself. Okay, my 2.5's cancel, so I'm left with x equals,
0.8.
let's see, I bet you're right, 2.5, oh, my bad, 2 divided by 2.5, that's what I'm typing, 0.8, awesome, 0.8, okay, so, remember, our solution to a system of equations is a coordinate, an x and a y. So we know that our x value now is 0.8. We've got our x. What is missing from our answer?
Y.
Our y value. So now that we have x, what can we do to find y?
You could just plug that x in and figure out the equation.
Yeah, absolutely. So I could just take this x of 0.8 and plug it into either one of these equations here. I'm going to do the top one because it doesn't have a fraction and it'll probably give us a slightly better answer, but Well, it'll give us the same answer, but it might be a little bit less difficult to work with. So to do that, I'm just going to I'm going to draw a line and do it down here so I have room. Y equals 2 times x minus 1, and my x is 0.8. Now all I got to do is solve, and I'm going to have my y. So 2 times 0.8, 1.6. Y equals 1.6 minus 1. And what is 1.6 minus 1? You should get about 0.6. Okay, so where am I going to put that y value?
Beside 0.8.
Right up here in my coordinate, 0.6. So I know they're not pretty whole numbers, but by using substitution, we are able to come up with the same answer. Same answer. So what you're really doing here is when you have these two equations, you're just going to flip-flop the other half of the first one and put it in front of the second. You're kind of making it, you're doing mx plus b equals mx plus b, and you're solving for x first. Because y equals mx plus b. So if y equals mx plus b, then mx plus b equals mx plus b. I know it's a little tricky to wrap your head around.
Well, I always find it funny when you say it like that, because it's almost like 2 is equal to 2.
Yeah.
That's absolutely true.
Uh-huh.
We're just breaking it down to that point.
Right, right. Absolutely. Let's do another one of these, okay? We'll try to make it not so overwhelming. We'll do some more and more until we feel a little better. Anybody need to write any more of this? Okay. Let me see. Let's do, let me find one that we did earlier that does have a good answer. Let's do y equals 3 over 2x minus 2 and y equals negative 1/2 x plus 2. I know that we're going to get a nice whole number as our coordinate, because we did this problem earlier by graphing. So we've got our system of equations and we want to solve by substitution. So we've got two options. I see in my first equation y is equal to 3 over 2x minus 2. And in my second equation, I've got y is equal to negative 1/2 x plus 2. So I've got two options here. I can either replace the y in the first equation with this, or I could replace the y in the second equation with that. Really all I'm doing is setting 3x minus 2 equal to negative 1/2 x plus 2. We're getting rid of the y so we can solve for x first, okay? So either way, you're going to get the same answer. Let's just go top to bottom, left to right. I'm going to put 3/2 x minus 2 first. Equals negative 1/2 x plus 2. Okay, you guys see that? Awesome. Okay, so this will be a little bit nicer to add and subtract our x's since we've got a common denominator here. They're both in halves. I've got 3 halves, I've got -1 half. What should we do first?
Bring the x over.
Figure it, yeah.
Yeah, which x? Do we want to mess with 3/2 or -1 half?
1/2.
1/2.
Yeah, so how do I bring this over? What should I write under it?
Plus 1/2.
Yes, I'm going to write plus 1/2 x on both sides. Okay, and what happens to my -1/2 x and my +1/2 x? They cancel. Those are gone. And now I can add here 3/2 plus 1/2. All you got to do is add the numerators. What's that going to give you? The top numbers.
4.
Yep, 3 plus 1 is 4/2 x. Now we could simplify this. Let's simplify it. What's 4 divided by 2? 2. So let's cross it off and write 2x instead. What comes next?
Bring everything down.
Bring everything down. I still have -2 on this side. Equals
Plus
2.
2. Wow. 2, 2, 2, 2.
A lot of 2's. Okay, what's next?
Add 2.
Add 2. Good. Okay, my 2's on my left side will cancel. And that'll leave me with 2 times x equals 4. All right.
Divide by 2.
Yep, we've got 2 times x. To get rid of that multiplication, we divide. We use our inverse operations. And our 2's cancel. So we're left with x is equal to
2.
2. All right, we've got our x. Perfect. So remember, when we solve a system of equations, what's our answer going to be looking like?
The x will be a 2,
Uh-huh.
and then our y is just going to be filling in where the x was.
Yeah, exactly. So we need to solve for y now. We have our x. So we can choose to put x is 2 into either our top equation or our bottom one. Either one's going to work. Which one do you guys want to do? The top one? All right, let's do that. So I have y equals 3/2 times x minus 2. And our x was 2. Okay, quick and easy trick real fast for whenever you've got 3/2 times 2. Remember, whenever we have a division problem, we cancel that denominator out by multiplying by the same number. And since we're doing that same thing here, we could just cross off these 2's.
3.
Do you guys agree with that? Does that make sense to y'all?
That's the answer I got.
Awesome. So these 2's end up canceling each other out. And we really just have y equals 3 minus 2. What's that going to make our y?
1.
Y is 1. So that's going to go in our coordinate. And that's our answer. It's not so bad. Not so bad. I know it's not as fun as graphing linear inequalities, but it's still interesting how we can do that to come up with our answer. And guys, if you wanted to, you could look back at where we graphed that exact same one. We got the same answer. See that? It works. Works the same. Okay. You want to run through some more of those?
Sure.
All right. I can't promise they're all going to be pretty answers like that, though. So we'll just see what happens. Let's do... How about this? Let's do these equations from that exit ticket, and let's see if we come up with something similar to this weird coordinate here. So I've got y equals 3x plus 1 and I've got
Negative.
y equals -5/2 x plus 5. Okay, what's our first step here?
I'm gonna take the top and bring it down to the bottom line.
So make it 3x plus 1 equals -5/2x plus
Yes.
5? Awesome, sounds good. So we are going to take 3x plus 1 because it's equal to y, and we're going to plug it in for the y in our second equation right here, which is going to give us 3x plus 1 equals -5/2x plus 5. Okay. What should we do now?
Bring the x over.
Yeah, let's bring our x over. Which one?
Negative.
Yeah, let's get rid of -5/2x. So we'll add 5/2x to both sides. Okay, so 3 plus 5/2. 5.5, you guys getting the same thing?
What I got?
I'll double check just to be sure. I bet you're right. 3 plus parentheses 5 divided by 2. This is how I typed it in my calculator. Okay, enter. 5.5. Awesome. So I've got 5.5x plus 1 equals 5. Is everybody to this point?
Yes.
All right. Okay, is everybody with us? Tasha, you with us? Awesome. Okay, what should we do from here?
No.
Get rid of the one.
Yeah, get rid of this 1 first. So -1 on both sides. They cancel. I've got 5.5x equals 4. Now what? Divide. Good. So 4 divided by 5.5 is going to be 7/2 repeating. 7/2, 7/2, 7/2, 7/2. You get something different?
I just put 0.8.
Yeah, you could absolutely round. Well, actually, this would round down to 0.7 because the number beside it is 2, which is less than 5. Yeah. So we would round down in that case. Now, if you wanted to round to the hundreds place, you could do 0.73. But we wouldn't quite get to 0.8. So let me write that out. We did divided by 5.5. And we got x equals 0.72. This is how to tell that a decimal's repeating. You draw a line over it. So 0.72 repeating. Anybody get something different?
I did, but I was doing it wrong.
What'd you do instead?
I put it into a wrong number.
Oh, okay, I get you. Well, that'll do it. That'll do it.
Every time.
Okay, and guys, let's look back to the point that we estimated. We guessed about 0.75. Michael, that was the point you guessed, I remember. That was pretty darn close. Pretty darn close. We got 0.72 repeating. We guessed 0.75. That's great. So let's see if we get close to 3.1 for our y, because that's what our estimate was. So we found our x. Let's go ahead and start a coordinate and put the x in there. And how do we solve for y?
Put y, well, you would plug 0.72 in that.
Yes, let's put 0.72 into, let's do the top equation. No fractions are nice. So that's going to give us y equals 3 times 0.72 plus 1. Okay, and tell me what you guys end up getting for
You
that.
don't need to do the repeating on this part, right?
That's okay if you don't. However, if it's already in your calculator, then you can just hit times and it'll take that repeating decimal. I wonder if it'll make a difference. Let's see.
Got 2.16.
I got 2.18.
1.6.
Let's see what happens if I 0.72 times 3. Yeah, 2.16. So it'll be a little different depending on what you type in. Let's go with 2.16. Okay, so y equals 2.16 plus 1. What's that going to give us?
That's gonna give us
3.16?
Yeah, 3.16. Makes me think of the verse. Yeah, that's exactly what I was thinking. John 3:16.
John 3:16.
I love it. I love it.
it.
I know. So that's our y value.
Man, that's crazy.
That was close.
Yeah, what? You must.
So look at that. We said as our estimate, that's incredible. We thought it was going to be about 0.75, about 3.1. Look at that. We were so close.
Whoa.
Wow.
0.72 and 3.16. Guys, y'all are just smart. Yeah. I love it. I love it. Okay. How are we feeling? We're
Good.
feeling good?
Good.
Good. Okay, here's what I'm thinking. We could introduce the other method of solving these. It's up to you guys.
Let's do it.
I feel like we've introduced a lot today, though.
Yes, it's fun.
You like it?
Yes.
I'm having a good time.
Okay, good.
Totally.
You guys feeling up to learning one more?
Sure.
Okay, and remember, these will be bonus points, so it's all right. Whew! All right, this next method is called elimination. Elimination. Now, this method is used most with standard form equations, with ax plus by equals c. So let me pull some of those out. Or, you know what, we'll just guess. I'll make some up. So I'm going to write to the side, mostly used with standard form. So I'm going to give you an equation, 2 equations. How about we try let's do 3x plus 4y equals 10. And 2x plus 3y equals, I don't know, 6. We'll see. Hopefully this doesn't turn out too ugly. We're gonna find out together. Okay, so when we use elimination to find the solution of a system of equations, basically you're doing exactly what the method is titled, elimination. You're choosing one of the variables, and I'm going to say usually we do x, and you are going to just completely eliminate it so that we can solve for y first. So here's how we do that. Whenever we have all these like terms lined up with each other, I've got x's, I've got y's, and then I've got non-variable numbers. We could set this up almost as if we are adding a polynomial. You guys learned about polynomials in here. That's something we cover a bit more in pre-algebra. It gets skipped over a little in algebra, but all a polynomial is it's a number statement, like a number equation type deal with more than one variable in it. So because there's x's and y's and they're different, this would be considered a type of polynomial. Pretend it's not an equation for this example. So we want to figure out a way to get rid of the x's first. So let me show you what we can do. If I were to make these numbers in front of the x's the same, but one's positive and one's negative, I can cancel them, right? So how about I take my top equation times 2 to make it 6x, and what if I take my bottom equation times negative 3 to make it negative 6x, so that when I put them together, I'll have 6x, take away 6x, and then I'll be left with whatever my y's are, so I can solve for y. Let me show you what's going to happen when I do that. Just before I try to explain it, I think it'll make more sense to see it. So I'm multiplying, so I'm going to be distributing this number here. Negative 3 times 2x is negative 6x. Negative 3 times 3y, that's going to give me minus 9y. Negative 3 times 6 is going to give me negative 18. Alright, is everybody with me so far with what I'm doing here? Awesome. So let's do this top one now. 2 times 3x, what's that? 6x. 2 times 4y, what's that? 8y. It's alright, I knew what you meant. And finally, 2 times 10, what is that? 20. Okay, so now I have here equations stacked on top of each other, and I'm going to look at this like an addition or a subtraction problem. So let's just go from top to bottom here. 6x minus 6x, what happens? What's that going to become?
It's going to eliminate itself.
It cancels. This is where the elimination happens. So no more x's. What is 8y minus 9y? Yeah, negative 1y. I'll bring down my equals. 20 minus 18? 2. And now I need to solve for y. Divide by negative 1. So y equals what?
Negative 1.
Oh, what's 2 divided by negative 1?
1.
No, girl.
Oh
Negative 2. Y'all know this. I think your brains are just, I'm giving you too much today. Y is negative 2. Now guys, we have a value for y. What can we do with that?
We can plug it into one of our first equations.
Yes, we can. We can just take this negative 2 and put it inside of one of these. Which one do y'all want to do?
Top one.
Top one. All right, let's do it. So I've got 3x plus 4y equals 10. My y is negative 2, so I'm going to put that in. Okay. What is 4 times negative 2?
Negative 8.
Yeah, so let's go ahead and make that into our equation. I've got 3x minus 8 equals 10. Okay, what happens next?
Let's add 8.
Yeah, let's add 8. We're trying to get the variable by itself, so we want to get rid of anything that's not the variable. So I'll bring down 3 times x equals 10 plus 8 is 18. Man, I accidentally gave you a real pretty one. Okay, what happens next? Divide by 3 on both sides, perfect. And the 3's cancel to give us x equals what? 6. So, just like that, we've got an x, we've got a y. What's our coordinate?
X.
6,
6.
-2.
6, -2. That's it. That's our solution. Not so bad, huh?
Nope.
Not so bad. Okay. So that's how we do elimination. I'll leave this up for you guys to write for a minute. We'll do one more example. And tomorrow we're going to start kind of the grand review of everything, because I would like for you guys to have the opportunity to take your final on Wednesday if you prefer. That way, if you feel like you want to do it again, you can do it again on Thursday, which I don't think any of you will need to. I think y'all got this. Okay, we have got about 10 minutes left. You guys want to do one more before we go?
Sure.
Okay. I don't know if we've ever gone this long, guys. Y'all are just focused today. I love it. Okay. Whew, let's do last one. 2x plus 3y equals 6. And let's do 10x plus, oh Lord, I don't know. 12y. I don't know. We'll see. We'll try that. 2x plus 3y equals 6. And 10x plus 12y equals 20. Let's try it. Okay, so if we want to use elimination to solve this, what could we multiply each of these equations by? Yeah, we could use our the coefficients attached to x. That's just the number attached to x, those constants. So we've got a 2 and a 10, so we're going to multiply them by each other, except for one of them's got to be negative so that it cancels. So we'll multiply the top equation by 10 and the bottom equation by what? -2. Oh, you guys are awesome. Okay. So let's do our distribution and see what happens. I'm going to write it out while you guys try to work it out on your own. I'm not going to announce it this time, and you guys just look up and see if you're doing it right. So
Question for you.
yeah, sure.
Besides just multiplying them by each other, couldn't we also do it by the least common multiple?
You absolutely could. You absolutely could. So if there was a number that was a little better, for instance, maybe the first number was 5, and yeah, maybe instead of multiplying both, you could just multiply the top one by 5 You could do that so that they're both 10s.
No.
That's very smart. You could absolutely do that.
Then that would leave so it would be okay with both being positive?
Well, you would have to either multiply the bottom by -1 or the top by -5. Does that make sense?
Smart, yeah.
Yes. Tasha, yes.
Okay, our numbers, I keep saying this, where are we getting our numbers from?
The numbers that we multiply by?
Yes, ma'am.
So here's where I'm getting them. I'm getting them from the x's. So to make these, my x's, have the same beginning number and cancel, what I'm doing is I'm taking 10 times 2, because I've got 10 down here. And then I'm taking that -2 times 10, because I've got 2 right here. So I'm flip-flopping the numbers so that they're going to be the same number but opposite. One's negative, one's... Does that make sense?
All right, it does now.
Okay,
Yes,
good.
Okay, thank you.
Good, good, good. And then I get -40. Okay, did everybody get up to about this point?
Yep.
Awesome. Okay, our x's are gone. 30 minus 24, what is that? I think it's 6y, yeah. And then 60 minus 40, that should be 20. Let's divide by 6. We're going to get y equals what? 3.3. Repeating. 3.3 repeating. So we got our y. And now we just need to solve for x. Yeah, sure. Let's use that top equation. Let's do 2x plus 3 times y, which is 3.3, equals 6.
That's funny.
Huh.
So if you have, let's say that's repeating 3 forever. We go ahead and put that in there.
Uh-huh.
It's just rewrite test since it's 3 times 3.3 as is 10.
That's right. 3 times 3.3 repeating is 10. Now, if you don't type the 3 repeating, you're going to get 9.9, and that's okay. So your answer will have a variation of 0.1, just because these calculators don't save repeating decimals very nicely.
How do you get a repeat? How do you get a repeat?
So the way to do the repeating is only to have a repeating answer. So if you wanted to keep that 3.3 repeating, you could just type in your 20 divided by 6 again. So 20 divided by 6 equals 3.3 repeating. And then I could do that times 3 right here. So just answer times 3.
Oh,
And that'll give you your nice pretty 10 instead of 9.9.
all right, cool, thank you.
Now, whenever we are doing problems like these, obviously I came up with these kind of on the fly, so we're getting some funny numbers. I'm going to be double, triple checking all of them before I give them to you on the final, especially. Even though they're just bonus points, I'll make sure you're not getting funky numbers. That way you know if you do get a funky number, you got to look at it and try it again. Okay, so we're going to subtract 10 from both sides and get 2x. I'm kind of rushing through this last part because it's really about time for y'all to go. Equals -4. Divide by 2. And you should get x equals about -2. All right. So what's our coordinate?
-2, 3, 3.
Perfect. -2 and 3.3-ish. Be close to that. Okay. Guys, as long as you've got the linear inequalities down, which I think you guys do, you're in great shape. The elimination and substitution, if you get that, awesome. Then you're doubly in shape. However, that's not going to affect your grade in a negative way if you don't get it yet.
I see what you did there.
It wouldn't. What did I do there? I don't even know what I did. What did I do?
Repeat what you said. It's
Not going to affect your grade in a negative. Ah. Oh, girl.
No,
right, y'all. Okay, I'm gonna go ahead and pause, or not pause, I'm gonna just end it. That's it.